Assalamu alaikum students. Today we start exercise 2.5. Now we differentiate trigonometric function, and by definition same process we have done in exercise 2.1. Now here we start to differentiate it. First we replace x by x plus delta x, then we subtract these values. Now we apply this formula: sin p minus sin q is equal to 2 cos p plus q over 2 and p minus q over 2. Here we have p 2x plus 2 delta x and q 2x, and replace these values in the formula, and this is thus simplified form is 2 cos 4x plus 2 delta x over 2 and sin delta x over delta x, because we divide by delta x, and we know that sin theta over theta is equal to 1. Therefore sin delta x over delta x is also equal to 1, and we put delta x tends to 0 in cos angle, and here we have the answer is 2 cos 2x. The same 4 steps of by definition. Now we solve these trigonometric functions by definition. Here we have tan 3x. We put x placed by x plus delta x, then subtract these values. For tan we change tan in sine over cos, and then taking LCM. Here we take their LCM, and then we complete a formula sine alpha minus beta, because if we have these angles name alpha, beta and alpha, we apply here formula sine alpha minus beta. This is the formula. Now here we complete this formula. Alpha is 3x plus 3 delta x and beta is 3x. 3x got by 3x. Now we have sine 3x in the numerator. We divide by delta x and multiply divide by 3. Now this form become 1, and the other in values we put delta x then 0. So it becomes cos square 3x and secant square 3x. Now in this question we have sin 2x plus cos 2x. In all x we replace x plus delta x, and then subtract these values and arrange sine by sine and cos by cos, and we apply on both values the sum and difference formula. Sin p minus sin q is equal to cos p plus q over 2 and sin p minus q over 2, and cos minus cos p minus cos q is equal to minus 2 sin p plus q over 2 and sin p minus q over 2. Now we put these values in this formula and then simplify. Now we common sin delta x and divide by delta x and taking limit. Now we have sin delta x over delta x is equal to 1 and put limit inside the angle of cos and sine, and this is its formal answer is 2 cos 2x and 2 sine 2x. So in this question we have cos x square, we replace x plus x delta x. Now first we replace x by x plus delta x, then we apply the formula cos p minus cos q minus 2 sin p plus q over 2 and sin p minus q over 2. We put values p and q. P is x plus delta x whole square and q is x square. Then we simplify these values, only simplify the value where we have a minus sign. Now we delta x common in angle. According to the formula we divide only by delta x, but to complete the formula sin theta by theta we multiply divide by sin x delta x 2x over 2, we multiply by this factor and the box value become 1 when we taking limit, and here it is answer 2 sin x square dot x. Now again we have tan square x, we replace x plus delta x, then we subtract these values. A square minus b square is equal to a minus b, a plus b. Now we change negative value in sine over cos, positive remains same till end, and we taking LCM of negative value, and here again we complete the formula sine alpha minus beta. Here alpha is x plus delta x and beta is x. Now we divide by delta x, and then taking limit. Now this is our answer is 2 cos x over cos square x. Now here we have formula. Question is cos square root x, we replace x by x plus delta x. Now then we apply the formula cos p minus cos q is equal to 2 minus 2 sin p plus q over 2 and sin p minus q over 2. Put these values. Now we divide by delta x, but we divide the same values as we have in the angle. In first angle we have x plus delta x square root plus x square root, and in second angle we have x plus delta x minus x square root. We divide by the same values, because if we multiply these two values it is equal to the delta x, and also we multiply 2 by 2, and the last value become equal to 1, because sine theta over theta is equal to 1, and in remaining portion we put delta x tends to 0. So this is the answer. We have derivatives of trigonometric functions. Remember these formulas. Derivative of sin x is cos x, derivative of cos x is minus sin x, and derivative of tan x is secant square. and derivative of cosecant x is minus cosecant cot x, and derivative of secant x is secant and tan, and derivative of cot x is minus cosecant square. Again, you note that the values which start with the letter C have negative sign, because cos, derivative of cos is minus, cosecant is minus, and cot is minus. Derivative of sin x is cos x. These are also proved by the same formula we have done in question number 1. Derivative of cos x is minus sin x. Derivative of tan x is secant square. Derivative of cosecant is minus cosecant cot, and derivative of secant is secant and tan, and derivative of cot is minus cosecant square. Now we start question number 2 and using these formulas. Here we have question number 2. Here we apply the product rule. Derivative of a dot b means derivative of a dot b plus a and derivative of b. We have two values, x square and secant 4x. We put these values in product rule. Derivative of x square is 2x. First we put these values in product rule and then we differentiate. Derivative of x square is 2x. The same formula of 2.3 n x n minus 1, and again there we have secant, and derivative of secant is secant and tan. Here we have the formula. Derivative of secant is secant and tan, and then we take derivative of angle. Its angle is 4x, and derivative of 4x is 4 because derivative of x is 1. Now in this question we have tan cube and secant square. Again we apply product rule. First we put these values in product rule, and derivative of tan 3 theta. Now here we apply power rule. We apply here formula n minus 1, 3 tan, and subtract 3 from minus 1, it becomes 2, and then derivative of base d by d theta of tan theta, and derivative of tan is secant square theta. Here we have formula. Derivative of tan is secant square. Remember these formulas. Now the derivative of secant square, again we apply power rule. 2 secant, 2 minus 1, its power become 1, and then derivative of secant is secant and tan. Again we apply here product rule. We differentiate with respect to theta. We put these values in product rule and we differentiate the values where we have d by d theta. Tan cube is 3 tan square, and then derivative of base also 2 secant power is 2 minus 1, and derivative of secant base. This is the answer. Now question number third part. Now again we apply the power rule. Power is 2 minus 1, and then derivative of base. Base is sin 2 theta minus cos 3 theta. Derivative of sin 2 theta is cos 2 theta dot 2. Derivative of sin is cos, and derivative of angle is 2 theta. Derivative of 2 theta is 2, and derivative of cos 3 theta is minus sin 3 theta, minus plus, and angle of 3 theta is 3. Now in this question we have cos square root x and sin x. Now here we have square root on angle, and in second we have square root on whole value. Derivative of cos square root x is, we first derivative of cos, it become minus sin x, and then derivative of angle, but in this value we differentiate power minus 1 and derivative of base sin x, it becomes cos x. Now derivative of angle is, its power is 1 by 2, 1 by 2, 1 by 2 minus 1, and here derivative of base is, derivative of sin x is cos x. Now this is your answer. Now this is question number 3. We have x cos y. We again apply product rule. Derivative of x is 1. Derivative of cos y is, cos is minus sine, and then angle derivative angle is y, so its derivative is dy by dx. Now we move dy by dx on left hand side, common, and then divide by this value. Now in this question we differentiate with respect to x. Derivative of x is 1. On right hand side we apply product rule. Derivative of y is dy by dx, and derivative of sine is cos y, and derivative of angle is dy by dx. We divide this value on by 1, and this is your answer. Okay student, try to solve these 3 questions. This is your today's lesson. If you have any problems, send it to me. Jazakallah.